Starting with the last problem of pyramid, a hexagonal pyramid of base 30 mm and axis 80 mm long has one of its triangular surface 45 degree to the VP. Draw the projection when the base edge of the triangular face is inclined at 50 degree to HP and parallel to VP. So here one of the triangular face is inclined at 45 degree to the VP. So we need to start with base entirely lying in the VP, so that will be seen as a true shape in the front view. So we need to start with the hexagonal base above the XY because that will be seen as a true shape in the front view. So we'll draw the reference line first, then we'll start with the hexagon, drawing hexagon. For that we can use circle method. Since the base edge is given as 30 for hexagon, we can draw the circle of 30 mm radius. Okay. Now for hexagon, we can either divide with vertical diameter or horizontal diameter, but we want two edges of the hexagon to be perpendicular to XY, then only we can make that triangular surface inclined to the VP, because we want one of the base edge to be on right hand side. So now we will mark the arc with respect to this vertical diameter, so that we will obviously get two edges perpendicular to XY. So now we will complete the hexagon. So we are getting this edge perpendicular to XY on the right hand side. Now in addition to the base, we need to show the slant edges, just joining the opposite corners, which are the diagonals for that circle. So now for showing the slant edges, we will just join the opposite corners since it is a pyramid. Now we'll number, since it is front view, 1 dash, 2 dash, 3 dash, 4 dash, 5 dash and 6 dash, and again O dash, O dash. I will complete the corresponding top view. For that we will first mark the axis length. Starting with XY, the axis length is 80 mm. So we'll first mark the axis length of 80. This will be the apex, O dash. Now we'll produce the other corners only up to XY line. So 3, 4 up to XY line. Then 1, 6 also up to XY line only. So now we will join with the apex to get the slant edges in top view. And then we'll show the base. We'll get 1, 6 here, 2, 5 and 3, 4 along with the apex at the center. Now slant edges from 5 are visible to the object. Slant edge from 5 is visible, that will coincide with slant edge with from 2. So we can't see the axis, long dash, short dash, only a dark line. Now in second stage, we need condition with respect to VP because we are redrawing top view now. So for that, condition with the VP is given for one of its triangular faces 45 degree inclined to the VP. So the triangular face 3, 4, O is containing the base edge 3 dash 4 dash. So this triangular surface we can make it inclined at 45 degree to the VP. So we need to tilt this by 45 degree. So first I'll mark the angle 45 degree, keeping this 3 4 still on the VP. So with this we will mark the angle of 45 degree. And on this 45 degree we will mark the triangular surface, which is this length in top view 340. Now we'll complete the remaining triangle by using the other distances 1 6. For that we'll produce the arc. Then for 1 6 to O, we'll produce one more arc from O. I will complete the triangle outer boundary by dark lines. I will also mark center 2 to 5 with respect to 3 and 4. Okay, that will be again a dark line. So it is 2, 5, O, and this will be 1, 6. Again O. Now we'll complete the corresponding front view by dropping the projectors. 1 6 first, 2 5 O, then 3 4, then apex O. I will produce the corresponding projectors from front view. 2, then 1 dash 3 dash will coincide. We'll get a single projector. If it is not, then we have made some mistake. This should be coinciding. Then center, then 4 dash 6 dash is coincide, and then 5 dash. Okay. Now we'll mark the corresponding points 1 and 6. So 1 will be here, 1 dash, 6 dash will be here, then 2 dash and 5 dash, 2 dash will be here, 5 dash will be here, 3 dash and 4 dash, so 3 dash again here, 4 dash here, then center of the base O dash, and then the apex here, O dash. Now we'll first make the boundary arc 1 dash 2 dash, 1 dash 6 dash, 5 dash 6 dash, then O dash 2 dash is the slant edge lying on the boundary, then O dash 5 dash again slant edge lying on the boundary. Now this is the observer position. So for the observer, base is not entirely visible. Okay, so remaining edges of the base, which are 2 dash 3 dash, 3 dash 4 dash, and 4 dash 5 dash, are hidden because base is not visible to the observer. So all the 3 remaining edges are hidden for the observer. Now after completing the base, we are left with 4 slant edges, 1 dash O dash, 3 dash O dash, 4 dash O dash, and 6 dash O dash. Out of that, 1 6 to O means 1 O and 6 O are nearer to the observer, so they should be dark. 1 to O and then 6 to O should be dark. So 6 dash to O dash should be dark. Now we are left with 3 dash and 4 dash. Since 3 and 4 are the farthest corners from the observer, so every line, we have already marked 2 lines from 3 dash and 4 dash are as dotted, so obviously third should be also dotted because they are the farthest corners. So remaining 2 slant edges, 3 dash O dash and 4 dash O dash, should also be dotted. Now for the last stage, we need to redraw this front view, the next step. But before that, we'll mark the axis here, O dash, So for redrawing the front view, we need condition with HP. So we'll see which condition is given for HP. Draw the projection when the base edge of that triangular face is inclined at 50 degree to the HP. So now we need to use this 50 degree to the HP that is given for base edge of that triangular face. The triangular face which we made inclined at 45 degree to the BP, the angle phi is 45 degree. The notation for that triangular face is 340. Now the base edge of that triangular face means edge 3 and 4. Now in front view we are getting that edge as 3 dash 4 dash. If you see from the initial front view, first edge, we are getting the same true length for that base edge. So now this angle 50 degrees nothing but the true inclination theta for the true length. So now we can rotate this entire front view such that this 3 dash 4 dash will make an angle of 50 degree with the xy line. Okay, but again we need to check about the apex, whether it is nearer to the observer or away from the observer. Nothing is said, so we can either tilt this in clockwise or anti-clockwise direction. So we will go for anti-clockwise, that is apex nearer to the observer. We'll tilt like this. So for that we need this edge to be inclined at 50 degree. So while following the rectangle method, if we make this boundary of the rectangle inclined at 50 degree, then obviously we will get 3 dash 4 dash also inclined at 50 degree because those two lines are parallel to each other. So I'll start with this boundary of the rectangle inclined at 50 degree, then we'll rotate the entire diagram in anti-clockwise direction. So first I'll mark the angle 50 degree. We can take it on this side as near as possible because everything will be drawn on this side. So we have less space above, so we'll shift it here. So space utilization is also important. So we are marking this 50 here. And on this line, we'll mark this rectangle. If I am starting with here, then nothing will come below. So we are marking this boundary of the rectangle on that line, starting with this point. Now we'll draw the two perpendicular lines. But I think after marking here, 6 dash will come. Okay, it will not coincide. 5 dash will go here somewhere. Okay, it will not coincide with, or still you can transfer this somewhere here. Again the inclination will be same 50. So we'll mark so that it will not, two views will not intersect each other. So we are shifting slightly. So if I am starting here again, we'll mark this width of the rectangle again. Okay, then we'll draw two perpendiculars. Along which we will mark the length of the rectangle, that outer boundary. This length, both the lengths will be same. Slightly going above, but that is okay because apex is only coming here, so all my slant edges will be below that point. Okay, now marking the remaining points. So first, since we are tilting like this, apex will go above. So first on this line, will get this corner will come here. So from this corner I'll mark 1 dash. I'll get the same distance from 6 dash from opposite corner. So we can mark 1 dash and 6 dash from each corner along the width. So here I'll get 1 dash and here I'll get 6 dash. So 1 dash here, 6 dash here. Then we'll mark 5 dash and 2 dash. Again same distances from same corners. So I'll get 2 dash here and 5 dash here. This is 5 dash, this is 2 dash. Now we'll mark this center on which apex and o dash center of the base will lie. So for that we'll mark the center of the rectangle and we'll draw a parallel line through that. Okay. Now this intersection will give me the apex o dash. Now with o dash I can mark the center of the base o dash. So apex to center of the base I can cut here. Now we are left with 2 points 3 dash and 4 dash. For that we'll first mark the parallel distance from the outer boundary of the rectangle. Then we will draw a parallel line to the boundary of rectangle, that arc. Then from the center we'll get the distance for 3 dash and 4 dash, same on both the sides. Okay, with this distance we can mark 3 dash, 4 dash. So this will be 3 dash and this will be 4 dash. Now we'll join with the same visibility, outer boundary dark. Then remaining 3 edges of the base dotted. Again 3 dash, o dash and 4 dash, o dash dotted. And then 1 dash 6 dash, 1 dash o dash, 6 dash o dash dark. And last thing is axis, long dash short dash. Okay. Now after redrawing this, we'll complete the final top view. Plus 5 dash and 6 dash lightly inside. Then first will come 4 dash. Almost 2 dash and 1 dash are coinciding. Then I'll get 3 dash, then 2 dash, then 4 dash. Corresponding projectors from top view. And first produce this XY line, then move by O, then 1 6, and at the end apex. Okay, so we'll mark the points one by one. 5 first will be here, 6 from this projector, then 4 dash, so 4 will be on the XY, then O dash and 1 dash lying on the same. O dash is the center of the base, so I'll get O here and 1 will be here. Then 3 dash again on the XY line, So 3 on the xy, then 2 dash. So 2 is here, and then the apex. Now see, apex is at the bottom here. So this is the apex. This O is the center, this O is the apex. Now we'll first make the boundary dark. Base edge 5 to 6 dark, base edge 4 to 5 dark, then 3 to 4 dark. Then among the slant edges, O6 is on the boundary because 1 is on inside, so O6 is boundary, and O3 is again the boundary because 2 is inside. Now we'll see the remaining edges. Out of the remaining 3 base edges, 1, 6, 1, 2 and 2, 3, we'll see from observer point of view. Observer is lying here. So for observer, both 1 dash and 2 dash are farthest points. 2 dash is the farthest, so everything from 2 and 1 is also farthest. So everything from 1 and 2 will be dotted. So from each corner I am going to get 3 lines. First for point 2 I am getting 2 O, which is the slant edge. Then 2, 3, again the base edge dotted. Then 1, 2, again the base edge dotted. And from 1 we'll get 3 more lines. So 1 is already marked, 1 to 2. Then O to 1 is slant edge, again dotted, hidden. And then 1 to 6 again hidden. Now we are left with 5O and 4O. 5O, O dash 4 dash and 5 dash 4 dash, 5 dash O dash are nearer to observer, so they should be dark. So I'll make them dark. See here, 4 to O is almost coinciding with O to 2, so we will give the preference to dark line. Okay, O to 2 is dotted, but O to 4 is coinciding with O to 2, so we will give the preference to dark line. Now for 5 there is no line coinciding, so we'll draw O to 5 dark. Okay, so last thing remaining is axis. Long dash, short dash. Okay. Now nothing is said about the observer, that apex position, whether it is nearer to apex or nearer to the observer or away from the observer. So this problem in the third stage can be solved differently. We could have tilted this solid in clockwise direction also. Then the solution also is right. Now we'll show the dimensions. First is base edge. For hexagon, it is 30 mm. Then the axis height is given as 80 mm. Then for the triangular surface, angle of inclination with the VP is 45 degree, that is already shown. Now for last case, this 50 degree inclination is given for base edge of that triangular face. Means reference for our base edge was 3 dash 4 dash. So I can show that angle here. We initially started with this, and then by parallel line we are getting the same line, the same inclination here. So this angle is theta with the HP, which is 50 degree. Okay. So this completes the solution for this particular problem. If you want, you can check once again whether all lines or edges are drawn, nothing is missing. Okay. Here one thing is happening, that O2 dotted line is coinciding with O4 dark line. So we have shown dark line. So this completes the solution.